Perfect. Thanks so much. Thanks, Pasha. It was all because of you. All right, welcome everybody. I hope that you have had so far a good time at CERN. Is anybody here for the first time? Okay, a few hands. Great. Is anybody here from CERN? Perfect. A few hands as well. Lovely. All right. So that I have about 45 minutes with you, and we're going to discuss a topic that I'm been quite interested in this for quite a few years already. And let's see how it goes. I suppose that most of you have to deal with deploying applications or software to production. You may have encountered a few issues. And what we will see today will likely help you prevent some of these issues that you may have found in the past. Now, so my name is Andres Almiray, and I'm currently employed by Oracle. I'm not here as an Oracle employee. I want to talk about open source in general. One of the things that I like to do is travel around the world and discuss the experiences and technologies and projects that I have encountered across this time frame, most likely are open source or not. So I would like to call myself a seasoned sorcerer just because I like to do open source a lot. Anyway, that's the boring part. The interesting bit starts here a little bit about the story time. Now, I'm going to talk about my experiences, and maybe some of you have encountered something like this. So, in a regular day, we're just working on code, getting all those requirements from the customers, and we're just pushing things to production, and just building, and the occasional meeting, right? So we go just about our day like any other day, and then comes Friday. And we're just getting ready. Indeed, we're getting that mindset that, hey, we're going to have some plans on the weekend. We may go out with our friends and have some drinks and have some fun, go to parties, enjoy whatever. Just because we are here in Switzerland, you can also go to the mountains. I am a typical geek that would like to stay indoors. But since I moved to Switzerland, I now enjoy going out in nature. So this is one of the things that I like to do on weekends. Okay, so that's exactly the mindset that we have on a Friday. We're ready to go. We just try to wind down after lunch and then just take it slow, and boom, things happen. What happened? We don't know, and that's kind of the problem. So who remembers this? Yeah, left pad. This happened, when was it? Like 9 years ago. In the JavaScript environment, this is in Node, someone, because there was some problem happening eventually was fixed up, decided to unpublish a package, which happened to be consumed by more than 11,000 projects and applications out there. By unpublishing this package, the internet was broken, at least this is how the journalist reported, was broken for 3 days. We don't have that kind of breakage in Java thanks to Maven Central. But stuff like this can happen. But if you're speaking about Java, you might remember this one. Who had fun in December of 2021? Yes, exactly. Log4Shell happened. And to the dismay of some people, we're still dealing with the fallout of this to this day, still in 2025, 4 years later. There are still companies that are vulnerable to this problem. I'm not kidding. So, when these things happen, yes, all hell broke loose, and we got, our managers were shouting at us, our customers were shouting at us because no one knew what was going on. Were we vulnerable? Were we affected? How can we fix this? How fast can we fix this? How fast can we get the fix into production? So many different things. This was me, scrambling like crazy. Where do I look for? Where do I start looking into the answers? How can I put this into, how would I fix my cloud instances? How would I fix this into that particular server that nobody wants to touch? Because if you look at it in the wrong way, it's going to break. So many different ways, right? So we have many questions around. How can we first fix this thing? And secondly, how can we prevent this? And thirdly, if it were to happen again or something similar, how can we mitigate this problem? Because it's not a matter of if it's going to happen. It's a matter of when it's going to happen. So the answer for this, or kind of the answer for this, is we just have to look back into the past, how similar problems were solved, and what were the lessons learned in order to solve this problem. So who remembers how log4shell was fixed? See? Who remembers how leftpad and the other problems were fixed? We just have to go back and reread everything that happened and figure out where there was a new framework, a new library, a new tool, all the things that have happened in order to make this work. Okay, so certainly we can fix these things. We can do it. We just have to have the proper tools. Now, the first thing in order to prevent these things is testing. If we are not doing testing today, I'm afraid that we're doing things in the wrong way. It doesn't matter how you want to call it. It doesn't matter if it's just unit testing or integration or functional acceptance. It doesn't matter what it is. As long as you're doing some sort of testing, you're good. These are the words from Alberto Savoia, who used to have a company just dedicated on testing. This is back in 2006. It's almost 20 years ago. If you're just getting into unit testing today, you're already late, 20 years ago. So let that sink in. If your managers don't give you enough time and when you're setting up the time frames for building stuff and they say, you don't have enough time for testing, oh, hold on a second, red flag. We have to discuss this because problems will happen. It's not a matter, again, of if, it's a matter of when. The next thing is, once you have gone through that step and you're building production code and you're also doing testing code, there will be the time when you have to post a release. Now, you decide exactly when this is going to happen. Now, what I would propose is that releases have to be automated as much as you can. Some people believe that if they are the release master, then they have job security because they are the only ones that know how to touch that particular bash script or set up Python commands or whatever is what you have right there, right? I would suggest that find a tool that can help you automate as much as you can. I'm a big proponent of making releases boring. If you can click a button and then just push a release after some point in time, that's perfect. If you click that button and don't even think about what was going to happen in the release, that's even better than that. You also will have to make these releases a schedule. Now, you can choose any time frame you want. Personally, I would like to say that you want to release a particular project or a particular product every so often, every 2 weeks, every 2 months, have 2 releases every year or 4 releases a year. You decide. And you can talk with your customers, with your clients, or the other teams that are consuming your tools to see when it's better. Why is this a good idea? Because those consumers can decide when would be the best time to jump into the next version. If they know you're going to push a release every 3 months, and the release is coming up, let's say it's March and June and September and December, and we're talking in the middle of August, they will decide, I can jump into the next one that'll come out in September, or I'll wait until December. It's way, way better. Now, where should we publish our binaries? If you have browsed the vast set of projects that exist on GitHub, there's a wide range of options. But many projects will simply say on the README, these are the build instructions. You just have to have a Docker daemon, and you have to have this version on Java, or Go, or Python, and Maven, and Gradle, and then after following a big series of steps, you might get a binary that you can consume and use. Wouldn't it be much, much better that you say, if I am happy consuming binaries from Homebrew, Chocolatey, Winget, or Pacman, or so many other different package managers, would it be much better if I just simply say, hey, my binary is right there in the package manager. Just use a simple brew install my app, or Chocolatey, Choco install my app. Wouldn't that be much, much better? Yes, of course. But there is a catch. We, as producers, have to be aware how to deal with that particular package manager. There may be JSON or XML or YAML or so many different formats and files that we had to create explicitly to make sure that these binaries can be published easily into those package managers. Who has the time to learn about all these different things? If I want to publish to a wider range of package managers, you have to become an expert of all these different package managers, right? Well, what if we don't have to do that? If you are working with Go, then there is a project called Go Releaser that allows you to do all these things that I just described, and a few other things. Now, Go Releaser in recent, I think it was the last release, 2.5, they also added support for compiling and releasing binaries, not just for Go, for Rust and SIG as well. That's great. But we are in a Java-dominated or JavaScript-dominated conference, so Go Releaser wouldn't work there if you want to do that. Luckily for us, there is another tool called JReleaser. Now, this one works for everything. It has a J in the name because, well, it's built in Java. But it targets Java, Go, Rust, SIG, C++, OCaml, Haskell. Yeah, you can do Ruby, Perl, Python, any language. Why? Because this tool, as opposed to the other one, does not build the binaries for you. You have to use the same build tool as you're using right now, the same strategy that you use. But once you have the binaries, then the release steps comes in. Now, I can talk hours about this particular project because I just happen to be the author of JReleaser, and I do have some some swag, so I have stickers. But the point of this talk is not to showcase one tool or the other, but to let you know that when it comes to automation, there are tools out there that can help you, whether it's Go Releaser, it's JReleaser, or something else. Pick something that molds around your release process if you have it. So these two tools do not force you to go into a specific release process. It's the other way around. If you have a release process, then you can adapt the usage of the tool to go there. If you don't have a release process, these tools can certainly suggest you how to do things. Whether you want to do releases on a local environment or you want to do a release on a CI environment, you can reuse the same configuration. The way that JReleaser works is that you keep using your same build tools of choice. It's Maven, Gradle, Ant, Node, Cargo, you name it. You produce the binaries, you supply a model of configuration, how you want things to happen, and as a result, you can publish releases to GitHub, GitLab, or your custom Git instances. You can also create files for package managers, Homebrew, JBank, Snapcraft, and some others, and also announce a release when it's ready. You can publish it to Blue Sky, Mastodon, Twitter, even internal channels like Slack or Mattermost, or just send an email. So there's a wide variety of options that you can choose from. You don't have to configure everything, just pick what you need. This is what it can do. There's a lot of things that the project gives you an option to. So you just want to release is the blue column. If you want to create files for the package managers, is the column in the middle. Or if you want to announce, is the green column. But if you want to do everything together, you can invoke just one command, and boom, off you go. So you have this option to be as granular as needed or as coarse as you want it. But once you have done releases, and you have built your binaries, and you have pushed them and published them into local places, or I mean a remote place where the public and the general audience can consume them, how can we tell that, or at least I as a consumer, how can I tell that that binary is coming from the right person? Does anyone remember the xset exploit that happened earlier last year? There were two things that happened here. An attacker got access to the source code because the main contributor was already burned out. So he did some social engineering and got access to the credentials, and when the time came to do the malicious thing, this person tagged the release, everything was looking nice, and published some convenience binaries out there. It so happens that the binary that was published had malware installed on it, but it was supposed to match the source code that was tagged. That wasn't the case. It took a while for someone to detect that his system was running slower than before after he made an upgrade to that particular version of the xset library. And that's how eventually this exploit was discovered. If the binaries from this project would have been published with some sort of signatures, then it would have been a bit harder for this particular attacker to impersonate someone. Now, we have had digital signatures for quite some time with PGP, but it turns out that now there is, for the last 4 or 5 years, I want to say, there is this project called Sigstore that the idea behind this project is to revolutionize or to reimagine how we do digital signatures. It's way easier to create a key pair for a private and a public key pair with Sigstore. It's easier for you to sign an artifact or a container and then throw away the keys. You don't need the keys to verify what you have done, the signature, because that is the thing that is new about Sigstore. You have the option to create new keys. You have the option to sign the binaries. And once you perform that sign operation, that goes into a central registry. So that if for some reason you lose access to the keys, there's still that fingerprint and that registry that something happened, that myself, Andres Almiray, signed this binary with such keys at that time and blah, 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 all that information, said that you can use another tool, some kind of verifier from Sigstore, that can check that the binary that you downloaded actually matches the signing record that exists out there. So they call this the keyless signing. So whether you want to keep those keys around or you just want to rely on the public record of all the things that have been signed, it's up to you. The thing is that Sigstore now gives you this option. So you can sign and publish artifacts. It could be jar files if we're talking about Java. It could be just a regular blob, a binary, if you have compiled it with Go, or is it Rust, or you are publishing wheel files from Python. You can sign all these things. And again, all those operations will be registered in the public record. And what is it called? I think it's called, record with a K. And then you get this other thing called full show, which is the one that allows you to verify the record. So everything is out there in the public, so everybody can see what has happened. So it's way easier to do the things and way harder for an attacker to impersonate you. So sign, verify, and monitor the activity. Anyone can do this. Another thing that can happen is that if for some reason an attacker gains access to your code base and gets access to your signing keys, whether it's PGP or Sigstore, they can impersonate you. The other thing that we can protect ourselves is the origin. Let's say the binary that I'm supplying to you and putting out on these public places where you can download it from for convenience, I can somehow guarantee that it's coming from a very specific place where it was built. I can tell you, if I'm building on GitHub public, that I can tell you it was built on such instance at such time with this and these settings, so that if for whatever reason the signature were not to be compatible with what you were expecting, at least the origin, the provenance of that particular binary can be verified. So it gives you a little bit of redundancy. So it's way better, of course, if the checksums and the signatures and the provenance, everything matches. So that's good. For this, we have upcoming idea, methodology, framework called SLSA, Supply Chain Levels for Software Architectures. This is a project as well as Sigstores that have been auspiciated by the Open Source Software Foundation, or Open Source Security Foundation, OSSF. So the thing about SLSA, and you probably have encountered something like this when discussing software supply chain attacks, is that attackers can get at any point in time, at any point in the supply chain, and do bad stuff. So they can do social engineering to attack us as developers, as persons, so they can access to our credentials, access to systems. They can also get access to the source code and then inject malicious malware there. That will be, or they can even get into our toolchain. I believe it's well known that someone, some time ago, and by some time ago I mean years, he was able to get as a proof of concept an additional piece of code into, I think it was the GNU C++ compiler, in such a way that the toolchain was bootstrapped in such a way that he was able to get into and put a backdoor there, and then prove that, hey, you're consuming the regular C++ compiler from the GNU, that's perfect. I have access to computer there right now. And if we are not certain where things are coming from, again, this is why provenance is important, or they can get into the package, or they can do a middleman in attack, or they can attack one of our dependencies in the same way that they could attack our own project. So there's a lot of places where bad things could happen. Now, this is not that I want to scare you and what do we do? That's exactly why we're discussing these things. The previous things that I just mentioned, automated releases and SIG stores, and a few things that we're going to talk about later, can help you get a much better view into what we're doing, when we're doing things, and who is doing things. So in the case of SLSA, they have identified a series of levels where we can go through in terms of our development experience. And as we go up the levels, then we are adding more security. So we start at level 0. This is where most likely most of us are right now. Level 0 simply says we can build stuff. How? We don't know. Who does it? Who cares? When it happens? In which nodes? Whichever might be available, right? It just happens. On the first level, at least we are documenting how things are happening. Again, you keep using Maven and Cargo. You might decide to use Go Releaser and Releaser for your releases. At least you now have a set of tools that can help you automate most of the steps. Perfect. And now you can reproduce the build in the sense that if you follow those steps, you may get something out of that. Now, the next step is signing that provenance. So you're saying, I'm building my project in this set of nodes, or maybe this CI server farm, but I'm also saying that it's me or some other members of my team that are responsible for building this particular set of artifacts. Now, you also get additional metadata about where these things are coming from, but that's as much as you get. And then on level 3, what we're doing is we're trying to hardening all the different places where attackers can come in. So if we go back to slides, what we're trying to ensure is that all these different red places where an attacker could come in, we're saying we are certain that the build toolchain that we're using is the correct one, because we know who installed it, when they did it, which versions, if there are any verification mechanisms, so again, checksums and signatures of all these little tools, we had done that. Now, we also done it for the build environment. So whichever nodes are there, we know which version of Linux or Windows or Mac, all the different packages. We can track all those things. We can trace those. And if you ask for a particular bill of materials of all these things, we can supply it. And not only that, we can also verify it. Again, all these different steps. So in the end, SLSA right now offers a series of builders that you can run on GitHub. I think it's public GitHub. I think it might be GitHub Enterprise as well. There are documentations and a series of tools that allow you to also run your own SLSA in your own service if you're disconnected from GitHub. It might take a bit longer instead of just consuming what is already out there and pre-verified, but certainly something that you could do in your own organizations in case that you are concerned about more security and being sure that you know exactly what is being run and when and where. I mentioned earlier that SLSA and SIG store are hosted as the OpenSSF. There are other projects that are hosted by this foundation, and the idea about this foundation is to first give awareness about things that could happen, how can we prevent these things, the methodologies and tooling around it to help you prevent these things and get better when things get wrong. Well, we're not there yet. So we know how to build, we know when and where to build, we know how to identify who did it. We can also identify where the things were built, all these things, but do we know exactly what was built? Going back to Log4Shell, when we're scrambling like crazy to know, are we affected? Well, first thing is, are we consuming the dependency that is in trouble? Which version of Log4j was it? Do you remember? 1.4.12. Yes, and when it was fixed? 1.2.17 and onwards. So, if you know for a fact that you're running 1.16 or earlier, it's likely that you're affected. But how do you know you're using that dependency? Do you have access to the build? Maybe, maybe not. You have access to the binaries. It's probably a bunch of jars out there. If you see the jar file name, that's good. Now, it's also common that some people will remove the version numbers from the jar files because they also put the jar files on source control. Are there still anybody doing that? You'll be surprised. I'm glad that no one raised their hand, but there are still enterprises that do that. Why? Because it's convenient, because then you don't have to change the name, even though you replace the binary file. All right? The other thing that could happen is that some organizations, for reasons, which are also, there are good reasons to do this, they shade, they relocate, and they repackage dependencies. So you might not be able to see a Log4j 1.12 version, but the classes that were part of that package were repackaged in another jar or even were renamed. So this is way harder to tell if you are vulnerable to that particular attack. So if you are following the standard Maven conventions and the Gradle conventions, there's very likely that you define a set of dependencies, that you consume them from an artifact repository, whether it's at Maven Central or something else, is besides the point. But given that we have access to that, then you can create this file called SBOM. It stands for Software Bill of Materials. Now, SBOMs are not quite new. This existed for quite some time now. There are two different formats out there. There is SPDX and there's CycloneDX. Whichever one you pick is fine. There are tools that allow you to translate one format into another. There are preferences from one file to another because one format registers more information than the other. And these two formats work, whether it's Java, Go, Python, JavaScript, you name it, they work for it. The interesting bit about this is that I think it was in after Log4Shell came out, the Biden administration, so we're talking about the US, they came out with an executive order. By 2024, by the end of 24, if you want to deal with government agencies, you must provide SBOMs. The European Commission decided to do something similar called the Cyber Resilience Act. By November of last year, 2024, you have to provide SBOMs. So no longer is a matter of if I want to do it, it's a matter of you must do it. And this enforcement now comes, I think now it's 2 years that we have to comply with these rules. So by the end of 2026, if you are not producing SBOMs as part of your build, you will be out of the game. So pick your favorite, SPDX, CycloneDX. There are plugins for Maven, for Gradle, and for the other tool chains and the other ecosystems so that you can create these SBOMs. Now, why would you like to have this? An SBOM is nothing more than just a recipe that tells you this is the version number of a given project. The identifiers that we use for SBOMs are called Perl for package URLs. which define the ecosystem, whether it's Maven, whether it's Java, whether it's Gradle, Go, JavaScript, blah, blah, blah. And then some sort of identifier. In the case of Java, it will be the Maven coordinates. So it also includes the version number. And once we know that that is the given thing that we want to, that we have identified, then here's the set of dependencies. For each one of those dependencies, we also have the hashes and the versions and additional information. What is this thing good for? Well, we can now ask questions like, given that I know which versions and which dependencies were used or should be used for running this particular thing that you are providing me, I can now go check into a given set of databases and find out if any of those dependencies have any register vulnerabilities. And if that is the case, then you have access to other tools that allow you to migrate to the next version. So if you're on GitHub, you have access to Dependabot or Renovate. You have access to other tools. There are other companies that give you some sort of code scanners that can also give you ideas and links of the different places where dependencies might be out of date or may be vulnerable to a given set of problems. So what I would like to say about SBOMs is that right now, the focus of consuming these files are to find out if there are any vulnerabilities on a given set of dependencies that you may have in your projects. But because they also have additional information on these dependencies, you can also query things like, what are the licenses? Now, some companies may be in trouble if they include AGPL libraries into the projects, because that means if I want to release a commercial product and I'm consuming AGPL, then my whole product now has to become AGPL. Or if it's MIT, or if it's Apache, or some other license, it depends how you can do things, right? So the SBOM can give you this information. They list what is the version number of dependency, what are the checksums, where you can find it, and which license it has. So if you want to have a quick look at if you're compliant to those license restrictions that you may have to put forward into your project, into your product, then the SBOM can give you this information. So bottom line, SBOMs right now are being used to check for the vulnerabilities, but they can be used for more because it's just metadata about your project. There are tools like Sift that allow you to generate SBOMs for containers or for a given blob of metadata like a jar file. And Sift allows you to create BOMs or SBOMs in either the SPDX format or CycloneDX. And it can also be used to to do migrations or to convert from one format to the other. So you can generate also in JSON or XML. And Sift also has its own SBOM format, if I'm not mistaken. So it's one of other things. Now that you know that you have to use SBOMs and you have to produce SBOMs, there is just one more tool that you can have a look at, and hopefully it will give you the answers that you seek. If this tool doesn't give you that, then there is a bunch of other tools out there that you may have access to. Okay. But the next thing is, we know when to build, where to build, how to build, but one that we have access to that source code and to the build instructions and that we can verify that our tool chain is okay. Are we able to reproduce the same output? Now, what does this mean? There are some organizations that by law, they must comply with the following things. Here's the source code. Here's the tag of the repository. They give it to the customer. And they might give out convenient binaries as well. But the customer will ensure that these things are actually true by rebuilding from the same source code, from the same tag. And they will get their own binary. Now, they can do a comparison with the two binaries. And there is a tool out there called Diffoscope that kind of creates a diff between two different binaries. Kind of like you're doing get diff, and you get a nice report on when two files differ. You get the same thing, but for binaries. Now, this is one tool that has been put forward by this initiative called Reproducible Builds. And the thing about this is that if you have two binaries that allegedly are coming from the same code base, from the same tag, and you rebuild them into compatible rebuild environments, so you don't have access to the same nodes, because you're the customer, you're from the outside, you're rebuilding in some different set, but in a compatible environment. Once you have access to these binaries and you make a comparison, if everything is the same bit by bit, then you can prove that your code base is reproducible. And this is a nice thing to do, because now anyone can rebuild your environment and do the proper checks. So going back to the xset exploit, if the xset distribution of the source code, the code base, was deemed reproducible, by the moment that it was tagged and released, anyone who can have access to that source code and create a reproducible environment and do the check and say, yeah, by a binary that does not conform to the binary that was published. Because again, this one was already broken in some way. Now, this error would have been caught way, way, way faster if we had reproducible builds. Another thing that you can have with the reproducible builds is that you can have parallel builds. Because now you can ensure that doesn't matter much where you build or when you build it, you're going to get the same binaries. What I mentioned by law, and this, I think this is perhaps with some of the governmental offices, is once you produce some code and you release a particular product or library, months later or even years later, someone will attempt to rebuild that particular tag and check that what was produced can still be produced and is identical. If you are not reproducible, then that's a problem. What do you need to do in order to make things reproducible? Well, you go to reproduciblebuilds.org, and it's a series of documents that tells you, based on the source language, what you can do. If you're packaging archives, then one of the things that we can do, or we should do, is ensure that you have a reproducible timestamp. Pick any timestamp. Who was here earlier at the session from Matthias about how to build container images? He talked about that Jib and was it build packs? They chose a timestamp that is way in the past. And you can change that timestamp if you want to, but this is kind of like I think they chose the Linux epoch because it's the easiest one, so that everything that you build with these tools will always have a chosen timestamp. Personally, I prefer to use a different one. I choose the same timestamp as the git commit of the tag that I'm building. So in that way, I know these things are somehow related. Some of the people would prefer to use the Linux epoch or some other time that doesn't change. It doesn't matter which one, as long as that particular time that you have chosen is reproducible. The other thing is that your archive has to have a reproducible or a deterministic order of the entries. So all the folders come first, and then all the files, or whether it's alphanumeric, it doesn't matter which scheme you select, but as long as it's deterministic and it's reproducible. The other thing that you have to ensure is any text files that have some sort of mixed up in the order have to be reproducible. Who will think of, for example, that JSON files may not be reproducible? I mean, you have a set of tags and elements and arrays in a JSON, and you can do a semantic comparison of these two files, and they might be identical. It's the same configuration. But if a section is out of order, it's no longer reproducible. Again, semantically, yes. Syntactically, isn't. So just moving one element into a different position is enough for that JSON file or XML or YAML to deem your whole build no longer reproducible. As a matter of fact, it's a matter of just changing the executable bit of a given file to make a whole archive or a whole build no longer reproducible. These things that I'm just telling you about are discussed here in reproducible.org. There are tools that already give options to make things easier, to make it reproducible. So if you're building with Maven, it's a matter of just adding one timestamp, one property into your POM file, and you're good to go. If you're using Gradle, then you have to explicitly say that you want to have reproducible artifacts. You cannot set the timestamp. It's already fixed. In Maven, you can choose your timestamp. And I believe there are 2 additional settings that you have to set in Gradle to make those artifacts reproducible. If you use Go, Python, it has to be on the given build tool of choice. Again, it will be part of that particular discussion. So, default scope is a tool that you can use to verify that 2 binaries are identical or not. And in the case that they are not, it will tell you with a nice report of where things differ. And then you can make the changes and then go again. In the case of the Java ecosystem, there is a project out there called Reproducible Central. The idea behind it is to check as much as possible how many libraries that are published to Maven Central are actually reproducible. So this project has a set of reproducible environments where they clone the project and they download the reference artifacts from Maven Central, do a build of the project, they get the binaries, and then do the comparison with default scope. And if everything goes right, that particular version of the Maven library, Maven plugin, or what have you, will be deemed as reproducible. There's a growing list of projects out there that you can see, so you may be more confident or consuming a given dependency if it's listed as Reproducible Central. Now, of course, embracing these tools, these technologies, these methodologies come at a price. When are we going to do this? Do we have time to do this? We have deadlines, people, right? And we don't want to spend the weekends trying to solve these things. We have a 9-to-5 job, and we have to put things into production. When can we do these things? Well, don't be disappointed. I'm glad that we're here at CERN because this is a place where we can share a lot about information and we can experiment and we can do a lot of things. So what I would suggest to you is that anything that you saw at this talk or anything else at this conference, give it a try for yourself. See how it works in your own particular project, even if you have a project. And the next step will be build a proof of concept that touches that particular production code that you're dealing with in your daily work. Do a brown bag session. Tell your colleagues about it. If you have numbers, if someone else has put out numbers, how good things have become after embracing all these things, that's even better. So as long as we have facts and not opinions, then we can convince our peers. Then we can make things better. Yes, it's going to take time, but it's definitely worthwhile because I don't want to be like the bird that we saw earlier, scrambling like crazy whenever the next thing happens. Because now I know I can verify things from where they're coming, who produced them, when they were produced, if that person is the right person, if I have the right set of dependencies, if by any chance any of the dependencies that were packaged with that thing or were used to build the thing are vulnerable, no, or not, how I can upgrade them. And if worse comes to worse, if I need to rebuild the whole binary because I may not trust the binary that I push forward into GitHub, or I may not trust the binary that was coming from Brew or somewhere else. But if I know that that particular build is reproducible, then I create my own and I can do all the verifications. And of course, we can automate many things with all the tools that we have at our disposal. So keep calm and open source. If you have not contributed to open source before, let me tell you, it's quite easy. You find any issues with the things that we have discussed today overall in the whole conference, or any other dependencies or tools that you make use at your daily work, raise a ticket. File an issue. Tell the person at the other side of the wire, hey, I'm using your project, it's quite cool, I like it, but I found this, or what if we could do this other thing? And that's enough. You don't have to push source code. You don't have to push a test case. You don't have to contribute the source code in order to help open source. But if you have the time, you have the skills, and you have the passion, we'll be very happy to have your contribution. But at the very least, just letting us know that something is not working as it's supposed to be. Something is broken, something is working differently in an environment that we didn't foresee before, then that is enough. Let us know what's going on. this is everything that I have for you now. I hope that it was kind of a bit of a whirlwind tour of the different things that we have access to. But in the bottom line that I want to say is that there are other things that we as developers, whether we're just regular developers or we are DevOps or we are DevSecOps or whatever you want to call it, there are more concerns now that we have to take into account. These tools, SLSA, Reproducible Builds, and Sigstore, and GoReleaser, and JReleaser, can certainly help us get faster at the solutions that we want. And whenever a problem occurs, then we can have a list of all these SBOMs and metadata and files that we can use to verify if things have gone wrong or as worse as people will say they're gone, and how we can solve these problems. So this is everything that I have for you now. I hope that you take home some of the things that you have learned today, and just find the tools. If the tools that we discussed today do not fit your use case, there's likely to be another tool. And if there isn't, perhaps you might be inclined to create a tool or talk to someone that will be willing to create a tool that you need in order to make the work. Thanks so much. Any questions? Yes.
So I have my boring build, and I make a boring deploy on Friday, and on Saturday it says my clients come to me and say, you know, you have a bug, like, and it's fine. Is there any way to avoid it? I mean, do not deploy on Friday sounds like a stupid rule, but at least it works.
Well, so in my personal experience, again, I'm quite biased because I'm the author of JReleaser. Just being a project, it uses the previous version of the tool to release the next version. We have set up a build environment on GitHub such that every push to main creates a new snapshot release. So the next version is built with the previous snapshot. We have done this thousands of times. So when the time comes in, remember when I said something about scheduled releases? We, in this project, have a 2-month release cadence. So the people know that every even month of the year, we're going to push a release. So that would be February and April, June, blah, blah, blah. OK. So when that specific release comes in, it's a final release. We use the same configuration. But the important bit is that before that release comes out, we have hundreds of releases before that we have battle tested the configuration. So we're quite confident that when we push that release button, things are going to work out. My best story about these releases is that when we released version 1.0 of the tool, that was on a Sunday when I had a transatlantic flight to the US for another conference. I woke up that morning, I pushed that button at 7 in the morning. The build took an hour, and then make the announcement and all that. That was the least stressful thing that I had to do on that day because I have an international flight. And it just worked on a Sunday morning. So what I can suggest you is automate the releases with any tools that you have access to, and do releases as often as you can. Snapshot, early access. So when the time comes for do a final release or a tag release, then you know your release configuration is already working. Any other question? All right, well, thank you so much.